Hello, my name is Davis Binger, and let's talk about derivatives in polar coordinates. Today we will be looking at problem 2 of the 11.3 handout. We consider the polar function r equals 6 plus 3 cosine theta and find the vertical and horizontal tangent lines associated to this curve. Let's take a moment to recall how to take a derivative in polar coordinates. We have a polar function f of theta. The derivative dy dx as a function of theta is given by the following formula. In our case, our derivative will just be negative 3 sine theta, and we can plug in this derivative along with the original function in to find dy dx as a function of theta. Here we have our derivative as a function of theta, and now we can go about trying to find vertical and horizontal tangent lines. Let's start with horizontal lines. Horizontal lines will occur when the derivative is equal to 0. In other words, when dy dx as a function of theta is equal to 0. This will occur only when the numerator of our rational function is equal to 0. Thus we have the expression 6 plus 3 cosine theta times cosine theta minus 3 sine squared theta is equal to 0. Now this is a pretty intimidating looking expression, but the following approach will allow us to find the solutions. We will replace sine squared theta with 1 minus cosine squared theta. We will then have a quadratic equation in terms of cosine theta. Now, after some simplification, we can rewrite this as negative 1 plus 2 cosine theta plus 2 cosine squared theta equals 0. We'll make the substitution x equals cosine theta and look for the roots of the polynomial 2x squared plus 2x minus 1. Now, by the quadratic formula, the roots of this quadratic are plus or minus square root of 3 minus 1 over 2. Now, we made the relation cosine theta is equal to x. And this particular solution, the negative square root of 3 minus 1 over 2, is less than negative 1. Thus, there is no value of theta which is equal to this particular value. The only solution in terms of x that corresponds to a real solution to our equation negative 1 plus 2 cosine theta plus 2 cosine squared theta will be the values of x, which is the square root of 3 minus 1 over 2. So we're looking for theta which satisfy this equation. In the interval from 0 to 2 pi, the only theta which satisfy this relation, cosine inverse the square root of 3 minus 1 over 2, and 2 pi minus cosine inverse square root of 3 minus 1 over 2. These represents the two theta values which have horizontal tangent lines. For the vertical tangent lines, this will happen when the denominator of our rational function is equal to 0, i.e. when 0 is equal to negative 6 plus 3 cosine theta sine theta minus 3 sine theta cosine theta is equal to 0. This simplifies to negative 6 sine theta times 1 plus cosine theta. So this equation will have solutions when sine theta is equal to 0 or when cosine theta is equal to 0. In other words, when theta is equal to 0 or equal to pi. Thank you for watching, and as always, if you have questions, you can leave them below or email me at binger@math.ohio-state.edu. Thank you, and have a good evening.